Hello guys, welcome to my channel. This is Ehsan, and in today's video we're having a design problem for this common source amplifier. And here these are the assumptions. The most important ones is the maximum value for W over L and the gain of this amplifier, which is 5, and the power must not exceed 1 milliwatt. In order to get these specifications, we're gonna have to design the value for RD. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button, and also the notification bell, so whenever I upload a new video you'll be aware of it. Let's jump into it. And by the way, this is a problem from the fundamentals of microelectronics by Behzad Razavi, chapter 7. Okay, now how we can solve this problem? Let me just start with AV. AV, which is 5, equals to, and by the way, this is the absolute value for AV. Okay, I forgot to put this. Okay, this is the absolute value for AV, because as you all know, the gain of common source amplifier is negative. What is the formula for gain? If you forget it, you can refer to my video about the common source amplifier, the gain voltage, which is GM times RD. So this gain is equals to 5 in this problem. And from this formula, I can extract that GM equals to 5 divided by RD. So I have GM with respect to RD, and I'm looking for RD by the end. This is my unknown that I'm gonna have to take care of it. Now, what is the formula for power? Why I called power? This is because GM is somehow related to the drain current of this amplifier, and power for this amplifier equals to VDD times I drain, and this is I drain, and this power had to be less than 1 milliwatt. So from here I can substitute VDD with 1.8 in this formula times ID less than 1 milliwatt. So I can calculate ID, which is less than 1 milliwatt divided by 1.8, and I'm using my calculator. I can get the result 0.55555, which is 556 milliamp. This is the boundary, this is the maximum value for I drain. Now I can get the relationship between GM and IAD. GM equals to one of the formulas, because as you all know, we have 3 different formulas for GM, and by these data I can use this formula: square root of 2 times mu and C oxide W over L times IAD. I can calculate I drain with respect to GM. So here we have I drain. If take the power of 2 for both sides, and by using some simple calculation I can get that GM squared divided by 2 mu and C oxide W over L. So this I drain had to be less than 0.556, and remember this is in milliamp. So GM squared is less than, or I forget the equal signs for these ones, 0. I can put the numbers in here: 2 times mu and C oxide, which is remember that this is in milliamp, this is had to be in milliamp per volt square, so this is 0.2 milliamp per volt squared times W over L, which is 20 divided by 0.18 W over L times I3, which is 0.556. So if I'm using my calculator, this is going to be GM squared, and I actually simplified this by taking the square root from both sides of this equation, and finally GM had to be less than or equals to 4.97. What is the unit for GM here? This is in milliamp and this is again in milliamp, so milliamp to the power of 2 divided by volt square, and taking the square root you can get the result in milliamp per volt. This is for GM. This is the maximum value for GM. Okay, this is the maximum value for GM. This is GM max, and using this formula along with this one you can get your result for RL drain, which is the purpose of this video. So here GM was 5 divided by RD, and another important formula, GM is less than or equals to 4.97 milliamp per volt. So I can take this and substitute it into this equation. So here 5 divided by RD less than or equals to 4.97 milliamp per volt. So by using simple calcula you can get that RD is greater than or equals to 5 divided by 4.97, which is equals to 1.006 kilo ohm, because this is in milliamp per volt, so this is in kilo ohm. This is a minimum value for RD in order to get this design in this having a gain of 5, and the power must not exceed 1 milliwatt with this W over L. This is the answer for R3, 1.006 kilo ohm. I hope you like this video, and if you have any questions let me know on the comment section. I will see you in the next video.